The next point to be considered, my dear friends, and that is about the state of a system. Now, when you talk about a state of a system, if you remember, I was talking about 4 primary properties. I gave 2 names also to those properties. The number 1 was variable property, and the number 2, and that is macroscopic properties. Yes, those were temperature, pressure, volume, composition. Now, what do you mean by a state of a system is that the values of the variable properties are going to be specified, or I'll use the word fixed, at a fixed time. Okay, now what does it mean? I'll give you a simple example with respect to temperature. Now, if I set a time, that means at 6 o'clock in the morning, and I give you a thermometer and I tell you that please tell me what is the temperature of the room, your answer will be only one, fixed. Okay, say for example 25 degrees Celsius. The time is fixed, the value is fixed. At 12 noon, probably you will say the temperature is 32 degrees Celsius. But there also, the time is fixed, is 12 noon. So the temperature also has one single value, that is 32 degrees Celsius. This is what it means. The value of the variable property is specified. It's one single well-defined value when the time is fixed. Okay, you must be thinking that you talk about variable properties and now he's talking about fixed. Please try to understand, my dear friends. Confusion मत कीजिएगा. मैंने ज़रूर बोला था आपको कि ये वेरिएबल है. क्यों? क्योंकि वक्त बदलता है तो इसकी वैल्यू में बदलाव आता है. मैं यहाँ पर क्या बोल रहा हूँ देख लीजिए. फिक्स टाइम लिखा है, मतलब एक वक्त पे टेम्परेचर का वैल्यू एक ही होगा. इसे हम लोग क्या बोलते हैं? स्टेट ऑफ द सिस्टम. आई बात समझ में? ओके. सो फॉर एग्जाम्पल, मैं एक बीकर लेता हूं. I'll take a beaker. I fill a gas into this. Okay? And then I introduce a piston. ये एक piston है. Weightless and a frictionless piston. Now what do you mean by this? Okay, weightless मतलब जिसका कोई वजन नहीं है, हल्का है. Frictionless, it doesn't have any friction. So that means it can move very freely up and down, depending upon the nature of the gas, depending upon the pressure acting on the piston. आपको पता है अच्छी तरीके से gas can undergo expansion as well as contraction. अभी piston itself doesn't have any weight, piston itself doesn't have any friction. So it means what? If the gas expands, the piston will be lifted upwards. If the gas contracts, the piston will go downwards. जब हम गैस की बात करते हैं तो हमारे पास प्रेशर का वैल्यू होता है. प्रेशर एंड वॉल्यूम आर इनवर्सली प्रोपोर्शनल, तो वॉल्यूम का हमें वैल्यू होता है. टेम्परेचर सपोज इज 300 डिग्री सेल्सियस. सो प्रेशर इज फिक्स्ड, वॉल्यूम इज फिक्स्ड, टेम्परेचर इज फिक्स्ड, एंड आई कॉल इट एज व्हाट? स्टेट ऑफ द सिस्टम. आई बात समझ में? यस. तो लेट अस कंसीडर द सिस्टम इज P1, V1 एंड T1 एट अ टाइम T1. तो ये हो गया अपना एक स्टेट. इसको मैं नंबर कर देता हूं, एक नंबर देता हूं मैं उसको. ओके. नाउ आई गो फॉर अनदर केस. नाउ अनदर केस क्या करूंगा मैं? आई राइट डाउन P2, V2 एंड T2. नाउ दिस इज स्मॉल T2. नाउ एक बार बताना चाहूंगा, कैपिटल T इज टेम्परेचर, एंड इन दिस particular chapter we are going to consider temperature in the form of Kelvin. Right? Small t is time. Okay, so this is what the difference is between the small t and the capital T. Now, at a fixed time, the pressure, volume, temperature values are fixed, is defined. And therefore, this is also a state. So, मैं उसका mark कर देता हूँ as 2. Now, you compare state 1 and state 2. The values are different. The time is also different. So, with a change in time, the values are changing. And this, I call it as a change of state. What I call it as a change of state. Understood this? Concept is clear? So when the value of the variable property is fixed at a fixed time, at one time the value is specified, that is state. When the time changes, the value also changes. That is called as change of state. Okay? Now कई बार ऐसा भी होता है दोस्तों. ये देखो मैं आपको एक तीसरा example देना चाहता हूँ अभी आप लोग को. The third example is P1, V1, T1, okay, and I give here T3. Okay, see now what is the change which is taking place? The time is changing, but the values of the variable properties are remaining fixed. I give you a very simple example is an AC which is working in a room. Okay, and the lecture is going on. Say the lecture is for 2 hours. और मैंने AC का जो टेम्परेचर है वो सेट कर दिया रिमोट के जरिए 20 डिग्री सेल्सियस. तो इसका मतलब क्या हो गया? 2 घंटे तक टेम्परेचर 20 डिग्री सेल्सियस ही रहेगा. So the temperature remains constant. वक्त तो बदल रहा है, लेकिन the temperature is what? Constant. It is same throughout. And I will say that in that particular room there is balance with respect to temperature. क्या बोलेंगे हम उसको? Balance. Balance मतलब एक समान. Okay, this balance in technical words is also called as equilibrium. नाम तो सुना होगा. It is what? Equilibrium. So which type of equilibrium am I talking about? Which properties? Thermodynamic properties. Okay, and that's why I'm talking about thermodynamic equilibrium. So this is what we talk about. This is thermodynamic equilibrium. You getting me, my dear friends? Yes. So when the values of the variable property does not change with time, okay, this changes with time, so I call it as change of state, but it does not change with time. Okay, that is called as thermodynamic equilibrium. Now see, there are values over here: pressure, volume, temperature. Okay, one more I told you, that is what? Yes, concentration. Now it is not necessary, okay, and it is not always possible to keep all the parameters constant. It all depends upon the conditions. And accordingly, whichever parameter I keep constant, accordingly I got various types of equilibrium. Okay, and that is, I'll tell you which are those. Number 1, thermal equilibrium. नाम से समझ में आ जाएगा आपको thermal मतलब yes, temperature. So यहाँ पर हम बोलेंगे temperature is constant. Okay, next, and that is chemical. Chemical नाम से ही समझेगा आपको concentration remains constant. एक example दो आपको. Yes, calcium carbonate. When I heat this, okay, at a temperature of around 1000 Kelvin, it decomposes into calcium oxide and carbon dioxide. Carbon dioxide is a gas, उड़ जाएगा. Okay, तो सिस्टम में मेरे पास कैल्शियम कार्बोनेट था. अब कार्बन डाइऑक्साइड गैस उड़ जाएगा, मतलब वो सिस्टम के बाहर चला जाएगा. It will go into the surrounding. So now what the system has? Calcium oxide. Previously the system was having calcium carbonate. There is a change in the chemical composition, my dear friends. But then the condition applied, my dear friends. What is this? 1000 Kelvin. Okay, this is what the condition I'm talking about. अब मैं जब मेरे हाथ में मैं चौक लेता हूँ, चौक इस नॉर्मली इस कैल्शियम कार्बोनेट, तो मेरे हाथों में इतनी गर्मी नहीं है 1000 केल्विन की कि वो कार्बन डाइऑक्साइड का धुआं निकलना शुरू हो जाए. सो जब मैं हाथ में जब मैं इस चौक को पकड़ता हूँ तो उसमें कोई भी बदलाव नहीं होता विथ रिस्पेक्ट टू द केमिकल कंपोजिशन. और उस स्थिति को, उस सिचुएशन को, उस कंडीशन को मैं बोलूँगा केमिकल इक्विलिब्रियम. आई बात समझ में? सो दिस इज केमिकल इक्विलिब्रियम जहाँ पर केमिकल कंपोजिशन इज कांस्टेंट. ओके, एंड द थर्ड एंड द लास्ट वन इज, अब आपको समझ में आ ही भी गया होगा कि हम किसकी बात कर रहे हैं. एंड दैट इज वी टॉक अबाउट मैकेनिकल इक्विलिब्रियम. Now when I talk about mechanical equilibrium, so obviously we talk about pressure or volume being constant. Sometimes we carry out a process at constant pressure. Sometimes we carry out the process at constant volume. So depending upon that, we call that particular process to be under what? Mechanical equilibrium. You getting it, my dear friends? Alright, the concept is getting clear. So just take a recap. We start with what? State. State is nothing but the values of the variable properties are going to be fixed, specified, one at one time. If the time changes and the value changes, I call it as change of state. Many times the time changes, but the value remains the same. This is thermodynamic equilibrium. And then which particular value remains same, constant, accordingly we say thermal, mechanical and chemical. In thermal, the temperature is constant. In chemical, the chemical composition or concentration is constant. And last is mechanical, its pressure or volume is constant. Okay, this is what we talk about with respect to the equilibrium state. I hope this is made very clear to all of you all. My dear friends, now we go into the next concept, and that next concept is all about state function. Now what do you mean by a state function over here is? Function means its dependence. In maths, you must be hearing x is a function of y. So they are dependent on each other. So function is dependence. Now dependence on what? It is on state. Now this state is with respect to chemistry. Because I made it very clear. शुरुआत में बताया है मैंने कि थर्मोडायनामिक्स को हमें केमिस्ट्री के नजरिए से देखना है. केमिस्ट्री मतलब रिएक्शन होता है दोस्तों. रिएक्शन मतलब इज अ प्रोसेस ऑफ चेंज. So I need two substances, before the change and after the change. Okay, before the change I call it as initial, and after the change I call it as final. उसी initial को हम बोलते हैं reactants और final को हम बोलते हैं products. तो जब हम state की बात करते हैं दोस्तों, there are two states. One is an initial state and the other one is a final state. You understand that? And the properties which are dependent on that is called as state function. So how to define this is, we are going to talk about those properties whose values are dependent only on initial state and final state. And I underline this word only. Alright? So it means that whenever I got a reactant and a product, okay, so if I am talking about any property, its value will depend only and only on the nature of that reactant and the nature of the product. It is not at all concerned that how that reactant is getting converted into a product. हमें उससे कोई लेना देना नहीं है कि वो रिएक्टेंट किस तरीके से परिवर्तित हुआ है प्रोडक्ट में. क्या उसको एक स्टेप लगा, क्या उसको मल्टीपल स्टेप लगा, हमें उससे कोई लेना देना नहीं है. एक रिएक्शन लिख के देता हूं दोस्तों यहाँ पर, A getting converted into B. इतना तो आपको जरूर पता है कि दोनों अल्फाबेट्स अलग अलग हैं. अलग अलग है मतलब बदलाव हुआ है. बदलाव को हम बोलते हैं रिएक्शन, इसलिए मैंने इसको रिएक्शन बोला हुआ है. सो यहाँ पर इनिशियल स्टेट इज A, द फाइनल स्टेट इज B. तो ऐसी कई सारी प्रॉपर्टीज है दोस्तों जिनकी वैल्यूज सिर्फ और सिर्फ A और B का आधारित है. अब ये A B में कैसे परिवर्तित हुआ है, ये एक स्टेप में या 10 स्टेप में, हमें उससे कोई लेना देना नहीं है. और ऐसे प्रॉपर्टीज को हम क्या बोलते हैं? यस, स्टेट फंक्शन. और उसका सिंबल क्या है? डेल्टा. समझ में आई बात आपको? ओके, नेक्स्ट थिंग इज, इट्स डेल्टा का मतलब होता है डिफरेंस. अब आप लोगों ने वॉल्यूमेट्रिक एक्सपेरिमेंट जरूर किया होगा, टाइट्रेशन वाला. ओके, ब्यूरेट, ओके, कॉनिकल फ्लास्क, इंडिकेटर एक्सेट्रा एक्सेट्रा. आपने ऑब्जर्वेशन टेबल ड्रॉ किया होगा. ऑब्जर्वेशन टेबल इज फाइनल इनिशियल डिफरेंस. अब ये इनिशियल शुरुआत हमेशा आप 0 0 से करते हो. और सपोज आपका जो एंड पॉइंट है, ओके, फिनोफ्थेलिन यूज किया है और अगर आपको कलरलेस टू पिंक आ रहा है, सो इट इज एट 9.9. So initial is 0.0, the final is 9.9. So what is the difference? Okay, I'm sure you'll be telling me. It's of course it's 9.9. So how we got that difference? It's final minus initial. Same thing is over here. Final is product, initial is reactant. So it is products minus reactants. So the examples under this category, I say delta T. T मालूम है ना, बड़ा T है मतलब it is temperature. Delta is nothing but it is a symbol of state function. Formula मैंने बता दिया है आपको. Okay, it is final minus initial. So what we do is कि final state को हम लोग number 2 देंगे, initial को number 1 देंगे. So that's why we have delta T is equal to T2 minus of T1. So it's final minus initial. Similarly, if I say delta P, so क्या आएगा? P2 minus of P1. अगर मैंने आपको पूछा डेल्टा V, क्या बोलोगे? Yes? हाँ, सुनाई दे रहा है मुझे. Yes, बराबर है. It's V2 minus of V1. Getting it? Okay, so this is what we talk about with respect to state function. Look at my dear friends. All the properties are not such that it will depend only on the initial state and final state. I'll give an example also for this. Okay, and that is, imagine there is a 16-story tower building. Of course, so there will be lifts as well. Okay, so there are two friends who wants to meet their common friend and a common friend is residing on the 6th floor. So what will happen is that one of the friend will go by lift and the another will go by a staircase. So both of them will reach on the 6th floor. After reaching on the 6th floor, and if I say that both the friends have done the same amount of work, is that right? No ways. The person who has gone through the lift has done less work as compared to the person who has gone through staircase. In spite of the fact that both of them started from ground floor and ended their journey on the 6th floor, that the initial state and the final state is same, but the amount of work done is different. क्यों? क्योंकि दोस्तों रास्ते अलग अलग थे. एक लिफ्ट से गया और एक सीढ़ियों से गया है, तो रास्ते अलग अलग है तो वर्क अलग अलग है. समझ में आया? सो इससे बहुत क्लियर हो गया दैट वर्क एक ऐसा प्रॉपर्टी है जिसका वैल्यू विल डिपेंड ऑन द पाथ फॉलोड. Okay, in spite of the fact that the initial state and the final state is same. Okay, और ऐसे properties को what we call it as path function. So we go into the next category, and that is path function. Okay, function का meaning तो वही है, that is dependence, but this time the dependence is on what? Path. So what we have to say is we are talking about those properties whose values depends, I'll say it's dependent on the path followed. Okay, it's not related to the initial state and final state. Okay, so यहाँ पर independence किसका था? Path का. यहाँ पर independence किसका? Initial state as well as final state. And the example is work. The other example I give you is, and that is heat. I symbolize it as Q. So work W and heat is Q. These are the two prominent examples. Which comes under which category? Yes, the category of path function. Okay, so please be very careful. Don't write delta W or delta Q. Because delta is a symbol for state function and these two are path functions. So getting very clear now, absolutely clear, the difference between a state function and a path function. State function, all those properties whose values will depend only and only on initial state and final state. It does not depend upon, irrespective of whether the conversion takes place in one step or multiple steps. It's not bothered. And the second one is a path function. Okay, we are talking about all those properties whose values will depend upon the path. Okay, it depends upon the mechanism of the reaction, whether it takes place in one step, two steps, multiple steps, etc. It is independent of the initial state as well as final state. And please remember the two prominent examples for path function, and those are work as well as heat. Got it very well? Absolutely very clear? Yes. Next thing, my dear friends, we talk about, and that is called as process. Now, to begin with, what do you mean by a process? Process is very simple. It's just a transition. Transition means what? Change from one equilibrium state to another. Okay, transition का मतलब क्या होता है? बदलाव होता है. Okay, धीरे धीरे बदलाव होता है एक इक्विलिब्रियम स्टेट से दूसरे इक्विलिब्रियम स्टेट को, उससे हम लोग क्या बोलते हैं? प्रोसेस. अब अलग अलग प्रकार के प्रोसेसेस हैं डिपेंडिंग अपॉन विच पर्टिकुलर थर्मोडायनामिक प्रॉपर्टी वी आर कंसीडरिंग. So accordingly we begin with the first one is called as isothermal process. Okay, what we call it as isothermal process. Now please my dear friends, my intention is, okay, and the same thing is to be yours as well, try to understand the meaning of the word rather than trying to by heart it. Okay, please मत कीजिएगा ऐसा. Okay, जितना हो सके उतना शब्दों को समझने की कोशिश कीजिएगा, अपने आप कंसेप्ट सरल हो जाएंगे. Isothermal, iso means what? Same. Thermal means what is the first thing comes into mind? Temperature. Okay, so in an isothermal process, what we have to say is the temperature of the system remains constant, or I'll say it remains same. Okay, that is called as a isothermal process. Okay, constant है, same है, change नहीं होता है. Now, few minutes back, I have already explained you what do you mean by state function. उसका symbol भी मैंने बताया था आपको, याद आ रहा है? डेल्टा. डेल्टा का मतलब होता है डिफरेंस, इसका मतलब होता है चेंज, और यहाँ पर वो चेंज नहीं हो रहा है. So accordingly, what we are going to say now is delta T, that is change in temperature. The temperature is constant, change nahi ho raha, and if it is not going to change, will it have any value? No. And if it doesn't have any value, it will be what? Equal to 0 or not equal to 0? Yes, it has to be equal to 0. ये delta T का formula भी मैंने बताया था दोस्तों. It is T2 minus of T1. So in this case, the temperature is constant. So the value of T2 and the value of T1 is same. And the difference between the same number, you know very well, is 0. And therefore we say delta T is equal to what? 0. Also, one more thing which I want to say is that temperature and internal energy. Internal energy is symbolized as U. Both of them are dependent on each other. Or I will say they are function of each other. मालूम है ना, मैंने ये बताया था आपको, function मतलब dependence. So temperature is a function of internal energy. What is internal energy? I tell you in detail later on in this part of the chapter. But यहाँ पर सिर्फ इतना याद रखिएगा कि temperature is dependent on internal energy. इसका मतलब ये हो गया कि अगर temperature is constant, the internal energy is also constant. And if the internal energy is also constant, so that means there is no change. और अगर change नहीं हो रहा है, so we say that delta U is equal to 0. Understood this part? Fantastic. Also, I want to explain you one more concept with respect to isothermal process. Okay, I'll draw a diagram, see whether you can recollect this. Okay, in the previous part of this chapter, I've already explained you this. कुछ याद आ रहा है ये गोलाकार क्या था? Yes. Very, very intelligent students I have in front of me. Okay, and that is universe. ये red line क्या है? Boundary है. ये हिस्सा कौन सा है? System. This one is what? Surrounding. We are going to consider what? System. Because it is thermodynamics. The chapter is also about thermodynamics. Now, suppose if a reaction is taking place, A getting converted into B. Okay, and now what happens is, the heat is released. Okay, so out. Release means what? Out. Out को क्या बोला जाता है? Exo. So the reaction is exothermic. Okay, so as a result of which what happens is कि अगर suppose ये एक reaction मैंने बंद कमरे में किया, the temperature is going to be released, the heat is released, so temperature goes high. नहीं चलेगा ना? Because the process is what? Isothermal. I want the temperature has to be what? Constant. So what has to be done? The heat which is being trapped inside that particular room, because of which the temperature rises, I want to make sure that the temperature should not remain in that room, should not remain in the system. It has to go out in the surrounding, so that the temperature comes back to the original. समझा आप लोगों को? यानी अगर टेम्परेचर को मुझे कांस्टेंट रखना है, तो इस रिएक्शन की वजह से जो हीट रिलीज हुआ है, मुझे उसे सिस्टम में नहीं रखना है, मुझे उसको सराउंडिंग में भेज देना है, ताकि टेम्परेचर बरकरार रहे. Temperature remains constant. So this is what it is. System, surrounding, this is a exothermic process. आई बात समझ में? बहुत क्लियर हो गया? वेरी गुड. तो अभी एंडोथर्मिक तो आपको समझ में आ ही गया होगा. एंडोथर्मिक में हीट का ट्रांसफर ऐसा होता है, दिस वे, फ्रॉम सराउंडिंग टू सिस्टम. क्लियर हो गया ये आप लोग को? ओके, सो दिस इज व्हाट आई वांट यू टू अंडरस्टैंड विद रिस्पेक्ट टू व्हाट? आइसोथर्मल प्रोसेस. ओके, दूसरा है एंड दैट इज आइसोबेरिक प्रोसेस. Once again, I stress on the fact, try to understand the meaning behind this particular word. Okay, iso means same. Bar, it's a unit of pressure. क्या है वो? It's a unit of pressure. तो समझ में आ गया आप लोग को? And that is the pressure of the system remains constant. Okay, and that's why we say now डेल्टा P will be equal to 0. कभी कभी बच्चे लिखते थे P equal to 0, यहां पर भी कभी कभी बच्चे लिखते थे T is equal to 0. नहीं, टेम्परेचर का वैल्यू कोई भी होने दो, यहां पर प्रेशर का वैल्यू कोई भी होने दो, हमें उसके वैल्यू से कोई लेना देना नहीं है. हमें तो सिर्फ इतना देखना है कि वो जो भी वैल्यू है वो स्थिर रहे, उसमें कोई बदलाव ना हो. तो याद रखिएगा दोस्तों, नहीं तो अर्थ का अनर्थ हो जाएगा. ओके, अगर आपने लिखा T equal to 0 is absolutely wrong. Am I very clear with this? Great. So this was second process. कौन सा था वो? Isobaric process. उसी तरीके से तीसरा process है, and that is Isochoric process. Okay, इसमें अभी क्या बोलेंगे? core का मतलब होता है volume, and therefore we say the volume of the system remains constant. और अगर volume of the system remains constant, हम क्या लिखेंगे? Yes, once again the same thing, my dear friends. Delta V equal to 0. Don't say V equal to 0. याद है closed system? याद है मैंने बताया था आपको बीकर ढक्कन से रख देने का. The total amount of water will remain the same because the lid is also a part of the system. Alright, so that comes under this particular category, that is Isochoric process. तो बताइए दोस्तों, the three processes, are they very clear to you so far? There are still many processes to come, but first of all try to concentrate on the recap on these three processes. Isothermal, that is thermal मतलब temperature, iso मतलब same, so the temperature remains constant. Delta T equal to 0. Temperature, internal energy are related with each other, they are dependent on each other, so internal energy is constant. So U यहाँ पर है, इस internal energy का symbol है, so delta U is equal to 0. एक और बात याद रखिएगा कि during an exothermic process, for isothermal case, the heat will flow from system to surrounding. During an endothermic reaction, for an isothermal process, the heat is going to flow from surrounding to system. हीट का फ्लो होगा दोस्तों. कई बार क्या होता है दोस्तों, स्टूडेंट्स को लगता है हीट और टेम्परेचर दोनों सेम है. नहीं दोस्तों, टेम्परेचर इज द मेजर ऑफ द हॉटनेस ऑफ द बॉडी. ओके, शरीर कितना गर्म है उसको नापने के लिए हमें क्या चाहिए? टेम्परेचर. ओके, अपना बॉडी टेम्परेचर इज सो एंड सो. हम लोग ऐसा नहीं बोलते कि बॉडी का हीट इज सो एंड सो. Okay, and when you talk about heat, heat is a form of energy. So this is what is the difference between temperature and heat. तो याद रखिएगा, because many times the student makes this mistake. Isothermal, so temperature is constant, heat का flow नहीं होगा. नहीं, ऐसा नहीं है दोस्तों. टेम्परेचर का, मैं तो ऐसे बोलूंगा कि टेम्परेचर को बनाए रखने के लिए, कांस्टेंट रखने के लिए हीट का फ्लो होना जरूरी है दोस्तों. अगर हीट का फ्लो नहीं हुआ तो टेम्परेचर या तो बढ़ेगा या तो कम होगा, और इसलिए फिर हम आइसोथर्मल प्रोसेस नहीं बोल सकते. तो दोस्तों ये याद रखिएगा, हीट एंड टेम्परेचर आर डिफरेंट. Okay, next one is isobaric process. When we talk about isobaric process, bar, it's a unit of pressure. So iso means same. So that means we say that the pressure remains constant. Okay, so once again यहाँ पे क्या बोलेंगे आप? P equal to 0? नहीं, delta P is equal to 0. Next one is we have isochoric process. The volume is going to remain constant. Core मतलब it's volume, and that's why we say it is delta V equal to 0. समझ में आ गया आपको ये तीन processes? Yes? Very good. My dear friends, we now move on to the next process. If you remember, we have done with isothermal, temperature constant. We are done with isobaric, pressure constant. We are done with isochoric, volume constant. Now, the number fourth one, and that is called as Adiabatic process. Now, my dear friends, please remember that when you talk about Adiabatic process, ये दोस्तों एक ऐसा process है जहाँ पर ना तो heat अंदर आता है ना बाहर जाता है. Okay, so that means there is no exchange of heat. Now my dear friends, if I just consider exchange of heat as Q, and ये no लिखा है मैंने, so that means उसका कोई वैल्यू नहीं होगा, और अगर उसका कोई वैल्यू नहीं होगा तो वो क्या होगा? 0. So Q is equal to 0. इसका मतलब ये होता है दोस्तों कि अगर हम एक्सोथर्मिक रिएक्शन कंसीडर करें, हम बात करेंगे यहाँ पर एक बेहतरीन एग्जाम्पल, एंड दैट इज, अगर आपको याद आ रहा, मैंने आपको आइसोलेटेड सिस्टम पढ़ाया था टाइप्स ऑफ सिस्टम में, कि जहाँ पर एनर्जी एंड मैटर नन ऑफ देम आर गोइंग टू बी एक्सचेंज्ड. और वहां पर एग्जाम्पल दिया था मैंने हॉट टी इन अ थर्मस फ्लास्क, ये यहाँ पर एक बेहतरीन एग्जाम्पल है. So if I'm going to consider that example, एक exothermic reaction है, the heat is going to be liberated, लेकिन थर्मस फ्लास्क में हम लोग ये रिएक्शन कर रहे हैं तो पूरा आइसोलेटेड है और इसलिए वो हीट बाहर नहीं जाएगा, वो सिस्टम के अंदर ही रहेगा और सिस्टम के अंदर रहने की वजह से टेम्परेचर बढ़ेगा. सो दिस विल रिजल्ट इन अ इंक्रीज इन टेम्परेचर. We talk about exothermic reaction. Okay? When I talk about endothermic reaction, endo मतलब in, तो heat is going to be absorbed. Okay? अब heat क्या होगा? Absorb होगा. अब क्यों absorb होने की कोशिश हो रही? क्योंकि यहाँ पर अंदर heat नहीं है. Okay? अब बाहर से तो heat आ नहीं सकता. And as a result of which, what is going to happen is the temperature is going to decrease. Understood this? Alright? So this is what is the case that we need to consider. Temperature में changes आ रहा है. मैंने आपको isothermal process के दौरान बताया था कि temperature is a function of internal energy. So if the temperature changes, so the internal energy also will change. So therefore, I will say internal energy, symbol क्या है उसका? U. So U will also change. Clear? This is all about adiabatic process. Okay, this is process number 4. आगे बढ़ते दोस्तों, हम बात करेंगे about reversible process. जी हाँ, reversible process. नाम से ही अंदाजा आ गया होगा आपको कि हम किसके बारे में बात कर रहे हैं. Okay, whenever we talk about a reaction, okay, reactant getting converted into products, but many times what happens, the products converts back into the reactants. तो दो डायरेक्शंस होते हैं. So depending upon the directions, the reactions are categorized into two parts. First one, where we talk about only one way, only one direction, unidirection, so we call it as irreversible. But when there are two ways, the forward as well as backward, then we call it as reversible. So यहाँ पर इस प्रोसेस को समझने के लिए मैं आपको एक एग्जांपल देता हूँ. Let us consider a cylinder. एक सिलेंडर कंसिडर करेंगे, इसमें गैस भरा हुआ है. ओके, इसको फिट कर दीजिए विथ पिस्टन. इसके बारे में मैंने आपको पहले भी जिक्र किया था. अ पिस्टन विच इज गोइंग टू बी मूवेबल, इजीली मूवेबल, ऊपर नीचे आराम से मूव करेगा क्योंकि उसका कोई वजन नहीं है. इट इज वेटलेस, उसके पास कोई फ्रिक्शन नहीं है. ओके, एबिलिटी टू रेजिस्ट, दैट इज फ्रिक्शन, वो नहीं है, फ्रिक्शन लेस है. सो इसलिए वो इजीली मूवेबल है. ओके, नेक्स्ट थिंग इज, बाहर से हम लोग प्रेशर अप्लाई करते हैं. लेट अस कंसीडर दिस एन एक्सटर्नल प्रेशर. ओके, यहां पर गैस मौजूद है तो गैस का भी एक प्रेशर होगा. अब ये दोनों जो प्रेशर है, द वैल्यू ऑफ दोस प्रेशर विल डिसाइड what is going to happen to that particular gas. And how are we going to come to know what is going to happen to the gas? By the direction of the movement of the piston. दोस्तों आप जानते हैं अच्छी तरीके से, gases have a ability to undergo expansion as well as contraction. Alright? So if the gas is colorless, it becomes very difficult for us to find out exactly whether it is expansion or whether it is contraction. And that's the reason we have made use of a piston. Piston is something which is a solid object. So we can easily see whether it's going upwards or whether it's going downwards, and accordingly we can decide whether the gas undergoes expansion or contraction. Alright? So what will happen is, suppose condition number 1 is the pressure which is there of the gas, I can call it as the internal pressure, is going to be greater than the external pressure. Then the piston will move upwards and the gas will undergo expansion. Right? Now if the internal pressure is going to be lesser than the external pressure. Okay, if I increase the external pressure now, such that it exceeds the internal pressure. So what will happen is the piston will go downwards and there is going to be contraction. Okay? So expansion हुआ, फिर contraction. यानी the directions are two directions and they are opposite. And hence the process will be called as what? A reversible process. Okay? Now, what happens is, there are two types of forces which you need to remember. There is a driving force and there is an opposing force. So internal pressure I will call it as a driving force, external pressure I call it as an opposing force. अब ये जो डायरेक्शंस में जो बदलाव आ रहा है दोस्तों, वो तभी मुमकिन है जब ये दो फोर्स के बीच का जो फासला है वो कम है. Okay, if the difference is large, then the process will take place only in one direction. Suppose if I say the internal pressure is much larger than the external pressure, then what is going to happen? Even if I am going to increase the external pressure, nothing is going to happen. The piston will continue to move upwards. And अगर वो एक ही डायरेक्शन में चलता गया तो हम उसको रिवर्सिबल नहीं बोलेंगे दोस्तों, हम उसको इरिवर्सिबल बोलेंगे. इसलिए दोस्तों याद रखिएगा कि जो डिफरेंस है between the driving force and the opposing force should be infinite simile less. Infinite simile मतलब क्या है? Something which is representing to what? A higher proportion. So it has to be very less. Okay, very large है तो infinite simile large. Okay, यहाँ पर it has to be what? Very less. And that's why we say it is what? Infinite simile less. Okay, so as a result of which what will happen is, number one point is the direction can be changed by bringing about a small change in the driving force as well as opposing force. Okay, next one is there are two directions, both of which are opposite. So opposing directions. Alright, next one is the process is going to take place through infinite number of steps. इसका मतलब ये होता है कि बहुत सारे स्टेप्स लगने वाले हैं, और अगर बहुत सारे स्टेप्स लगेंगे तो जाहिर सी बात है ज़्यादा समय लगेगा, और जिस प्रोसेस को ज़्यादा समय लगता है उस प्रोसेस को हम क्या बोलते हैं? जी हाँ, स्लो प्रोसेस. हम उसको बोलेंगे स्लो प्रोसेस. Alright? और यहाँ पर एक और बात याद रखिएगा कि सिस्टम जो है it's always going to be in a mechanical equilibrium. I have already explained you this particular term before. It's always in a mechanical equilibrium with the surrounding. Okay, so these are the points that you need to keep in mind. Okay, so first of all is a reversible process. It's a process where there are these opposing directions by means of a small change taking place. ये मैंने आपको example दे दिया है. Okay, the points are the direction can be changed by bringing about small changes. Okay, either in the internal pressure or the external pressure. Directions are opposing. Okay, अगर एक expansion हो रहा है तो the piston is moving upwards. Contraction or the piston is moving downwards. So it's opposite directions. काफी समय लगता है. Why? Because it is proceeding through infinite number of steps. Okay, जैसे कि सिंपल सी बात है, अगर मुझे एक जगह से दूसरी जगह जाने का है और वापस से वहीं से मुझे पहले के पोजीशन पे आना है, तो मुझे जो टाइम कैलकुलेट करना होगा that has to be both the time. Okay, जैसे कि मेरे पास है पॉइंट A और मेरे पास है पॉइंट B. I go from A to B and I calculate the time. And if I stop over here at B and the process stops, that means it's only one direction. And one direction, that means it is irreversible. But then if I want to come back like this. So if A to B takes T1, B to A takes T2. So अगर मुझे irreversible consider करना है तो I'm going to consider only T1. लेकिन अगर मुझे reversible process consider करना है, I cannot just consider only T1. Okay, I need to consider also T2, T1 plus T2. और ये प्लस आया है दोस्तों, एडिशन आया है, तो एडिशन से द वैल्यू बढ़ता है. और किसका वैल्यू बढ़ रहा है? टाइम का. सो द टाइम वैल्यू इज मोर, इट्स टेकिंग मोर टाइम एंड मोर टाइम माय डियर फ्रेंड्स, एंड दैट्स व्हाई द प्रोसेस इज स्लो. ओके, एंड एज आई सेड, द सिस्टम इज ऑलवेज गोइंग टू बी व्हाट? A mechanical equilibrium with respect to the surrounding. And equilibrium, you know very well, that is same. Okay, there is going to be a balance between the system as well as the surrounding. You getting it this? Okay, so this is about the process which we are discussing, and that is called as reversible process. So my dear friends, what we have discussed so far is isothermal, the second one was isobaric, the third one isochoric, the fourth one adiabatic, and the fifth one is reversible. And I am very sure you have understood all these 5 processes. Yes? Okay.